Hey, welcome back, students. In this video, I want to go ahead and address how to identify the limiting reactant. Limiting reactants are quite interesting and fun to use because when the limiting reactant stops or when it runs out, the whole reaction stops. And so that means that no product is going to be produced beyond that point. So it's very important for us to identify which of the two reactants runs out first and how much of that reactant we're actually going to have. And so in the problem here, what I've gone ahead and done is prepared a sample problem for us. Notice that it's written, we see an equation here at the bottom, reaction equation here, and so we're going to go ahead and actually just start trying to answer this problem. But let's begin by reading the problem. Problem reads, based on the balanced reaction below, what would be the limiting reactant if 34.6 grams of carbon monoxide reacted with 88.1 grams of hydrogen gas? And it also wants to know how many grams of the methyl hydroxide are going to be produced. All right, and so let's go ahead and solve this. Begin by first starting here, and all we're going to do is write down the. All right, so I'm going to begin by selecting the lines and write a line at every plus sign, every arrow. And then the next item that we need to do is go ahead and translate the information. But let's look at the information in the actual section here. The important information for us is right here, 36.4 grams there, 88.1 grams of hydrogen gas. Those are the important points. So what we want to go ahead and do is go ahead and translate this information. All right, so what we need to do is transfer this information where it goes. Notice that the 34.6 grams that I identified, that's actually going to go right here. Oh, let me redo that with a pencil. So that's going to go right here, 34.6 grams of carbon monoxide, and then 88.1 grams of the H2. So the 88.1 goes there. Notice here that the two numbers that we've been provided are the two reactants. And that's essentially what we really want, because had we had two numbers that were not entirely reactant, this would not be a limiting reactant problem. Okay, so as you can see here, what we're going to have to find out is determine the molar mass for both of these compounds and then determine the number of moles before we can proceed to the next step. So if we do this, the molar mass of the carbon monoxide, we first have to take the mass of the carbon and then the oxygen. So let me just write this here. The carbon weighs 12.011 grams and the oxygen weighs 15.999. And so if we're going through this and actually getting that done, we'll have to add those two numbers up together, and that result is the following. All right, so that result there is going to be 28.01, and remember this is grams per mole. And then we'll do the same thing for the hydrogen gas, and that is going to be 2.016 grams per mole. Since we are moving in the downward direction here, trying to figure out the moles, what we are going to do is we're going to take the grams and we're going to divide it by the molar mass. So these two numbers are going to be divided for both of these columns. So let's go ahead and do that. We'll take the 34.6 and we're going to divide that by 28.01. In the carbon monoxide column, we get 1.2352 moles. And in the hydrogen column, take 88.1 and divide that by 2.016. That will give you 43.70 moles. Now that's a substantial amount. And so what we are going to need to do at this point is we are going to have to come in here and kind of calculate the amount that we're going to need. And so this is the way we're going to do this. We are going to take this number here, multiply it times 2, divide it by the 1, and that will give us the number in this category here. And so let's go ahead and do that. And let me just take care of that. So we'll take the 1.2352 times 2 divided by the 1, and it winds up giving me a number of 2.4704. And these are the number of moles of hydrogen gas needed if I begin with 1.2352 moles of carbon monoxide. And for the other number, we're going to start with this number here, go to the 1, multiply it there, divide it by the 2, and then that'll give us the number there. And so let's go ahead and take care of that math. And so we'll take 43.7 times 1 divided by 2 gives us a number of 21.85 moles. And so this number here, if you want to just make sure that you jot the right number here, this is going to be the moles needed, and this is the moles have in the previous category. So in order for us to determine whether we have a limiting reactant, what we're going to do is we're going to take the moles have and we're going to subtract the moles needed. So essentially what we're doing here is the following. We're going to take these two numbers and subtract them. Okay? And we're going to do the same thing here. And it only applies to these two that I'm putting in the box. Okay? If you do 1.235 divide minus 21.85, obviously this number here is the negative. So this is the limiting. And we're going to get excess over here. If you want to go ahead and calculate the excess, you definitely can. You take the 43.7 and you subtract 2.4704, and that gives you here 41.2296 moles excess. All right? And so having done that, now we know that the limiting reactant for us is actually going to be the carbon monoxide, which means we're going to have to use this number right there that I've just circled. And let me highlight it. Let me go ahead and circle it in red. Nope. Okay. And so we're going to use this number here to get to the other side. If we're trying to find the number of grams, what we're going to do is take the 1.2352 multiplied times 1 divided by 1, and that'll give us the answer for the number of moles. But we don't need to do that because the coefficients here are both 1 and 1 for these. And so all we really need to do at this point is take that number and write it down, 1.2352, and this is going to be moles. We do need to go in the upward direction here, and so in order for us to get to the question mark up top, we do need to find the molar mass. And let's go ahead and do that now. So what we'll do here is take the mass of 1 carbon, 4 hydrogens, and 1 oxygen. That molar mass is the following. All right, and so we wind up getting 32.042. This is going to be grams per mole. And since we're going in the upward direction, I'm going to multiply my molar mass and the number of moles. And that will tell you me the overall total mass for this particular compound produced. And so when we do that multiplication, we wind up getting 39.578 grams. And this here is your final answer. So I'm going to just double check it there. All right, and so that is the way we go ahead and solve this type of problem. It does take a little bit of time, but I've gone ahead and gone slowly in this problem here. Make sure you identify what the limiting reactant is, how much you've got, convert that to moles, and then use a mole ratio to get to the products. Remember, when you're moving down the grid that I've used here, you want to divide, and if you're moving up the grid, you multiply. If you have any questions, go ahead and see me in class, and until next time, go ahead and keep learning and subscribe.